Recording. Yay.
New book.
Yeah, so today it's first day of the fourth book, Concepts, Techniques and Models of Computer Programming, which is a suggestion from Marin, right?
I just realized we missed a huge opportunity. The
Hmm?
fourth book could have been about fourth. That would have been a pun.
Wow, that would be genius fun.
Oh man.
Oh well, we'll have another opportunity 10 books from now, I guess. Oh
uh,
no, 20 books for now from now because 14 is 14th,
Hmm?
not 10 fourth. Ugh,
yeah, that's gonna
what a
take like
waste.
2040 we reach there. Okay, so let's start by talking about the preface. So apparently Nathan and Marinho they are way more excited to talk about that. Let's talk about that. So what you guys want to
Well,
start with?
I
Well,
think that even before talking about the specifics part, I would like to comment about the whole, man.
Well, before you
It's
say
a.
that, just for the record,
Hmm.
I have the book. That this is it. Okay.
yep.
How is that so big, man?
Well, it's 1,000 pages. What did you expect?
I don't know. It doesn't. ah, It doesn't look like much on the PDF
Okay,
and
now you
reading
can
it.
say
But
Nathan.
yeah, it's a huge book, the physical one. Yeah, it's a fucking crime that book is not more well.
More well known?
Yes, that's exactly it. It's a fucking crime. Uh, for what I read of, well, so far, it's pretty uh short for the amount of stuff it was talking about. Also, pretty simple in the way it is describing it. Uh, yeah, and about a lot. It talks about a lot of like important stuff that it usually takes a lot more time for you to learn and gather just by not learning it all in one place or as they have there.
Yeah.
Uh, so yeah, I only might be a bit biased in the sense of maybe if that's the first time you are hearing about like all of it or most of it, then maybe it might be too short, as in
Wait,
there is
what
no
do you
way
mean
you
by
will
too short? We
absorb.
just read introduction. It's supposed to be
No,
short.
no. I mean, if that's your first contact with at least most of the ideas there, it might be too short for you to absorb it all. You see?
Well,
I
but it's
mean, there
saying that
are
the audience is
exercise.
not that. Oh,
Yeah, and
sorry,
also
Marinho.
there are exercises at the end of each chapter as well. So,
Oh, yeah, yeah. Uh, it says not regard. It is not to your first introduction to programming, sure. But still, even if that's right after that, maybe you're not mature enough to just like read as we did and just okay, sure, fine. You would have to spend a lot more time on it.
Oh, okay, that
probably.
yeah, okay. Okay, let's put it this way. If the only two languages you ever touched in your life are Python and JavaScript, then you're definitely not ready. Maybe.
Unless you spend a lot of time on JavaScript or doing some interesting stuff.
Yeah. So, well, I agree that if you are not still into programming or a little bit above into programming, you're not gonna be able to grasp fully. In particular, for example, the only thing that was definitely new to me was the whole data flow thing, as Marinho predicted before. Anyway.
The same case for me, by the way.
I
Yeah.
mean, data flow variables are amazing.
Yeah.
Okay,
Data
so you
flow
asked
variables.
what we wanted to talk about in the preface, right? Let's actually start with this first quote. The book opens with the that parable about the blind sages touching the elephant, right? I think it's very sad that this is a very accurate picture of the state of programming knowledge when you consider the average programmer. Like they
Yeah,
may know
that's
something about programming, but they don't really have a big picture in their head of. like the whole of programming, you know?
Yeah, let's read the quote, I think. Six blind sages were shown an elephant and met to discuss their experience. It's wonderful, said the first. An elephant is like a rope, slender and flexible. No, no, not at all, said the second. An elephant is like a tree, sturdily planted on the ground. Marvelous, said the third. An elephant is like a wall. Incredible, said the fourth. An elephant is a tube filled with water. What a strange piecemeal beast this is, said the fifth. Strange indeed, said the sixth. But there must be some underlying harmony. Let us investigate the matter further.
I
Uh,
Yeah,
think I
they
only now understand what they were talking about with the rope and the tube filled up with water.
yeah, you see, because the sages are blind, right? Which means they can't see the elephant. They have to touch it with their hands. And each of them touches a different part. So one touches the trunk, one touches the tail, the other the legs, and one of them touches the side of the elephant. And it's like they're all
hmm
completely different, right?
Yeah, but
And
they.
yes,
hmm
they are parts of the same entity, right? It's just they can't see the entire entity, so they can't figure out uh, immediately how the parts fit together.
Yeah,
You know?
it's an idea that you're what you actually are interacting with is just you're touching multiple branches of the same tree.
Yeah,
You can't see the whole picture, right?
Actually, that's a very controversial take if you think about it. Arguing that there is a foundation that everybody should strive towards, that's very controversial apparently.
Mm.
Because
why?
because the the myth of specialization points towards the opposite direction.
Hmm.
I mean, I think there is something regarding the rate of it, as in you should not pursue knowing everything that exists without also taking your time and well taking a good look on each piece, you know. So there is an equilibrium between taking a good look at individual pieces and also taking a step back and trying to comprehend the whole.
Yeah, but that's the problem. It's because to me that whole balance that you're mentioning is completely off when people talk about being specialists in something. Because when they go that far, they actually they lose the ability to see similarities and connections between the pieces.
Mm.
And that's kind of the problem, which is for me the reason that there's no way around it, dudes. You gotta try to start for foundations first, because
Yeah.
then like and it's not that it's not there's no benefits in doing that. So for example, I was working with Marinho in a particular thing at work, and then I was having some trouble understanding what the heck was going on with that closure code, and then Marinho said, Lemos, this is a monad, dude. And then it clicked, even though it was not really monads in closure. It is just something that I could relate to and make the bridge, and now I have an intuition, and that like saved up tons of time.
Mm.
And the reason that Marin was able to do that is because he understood that whatever I was touching is related to that topic, and then he could just give me that hint, and I could do the bridge myself. That's the benefit of knowing foundation stuff.
Yeah, foundations are important, no matter what anybody says.
Yeah, no matter what anybody says, that's true. Okay, so the first thing that I would like to point about the preface that I think is interesting is that somewhere in here they talk about the approach that they won't be doing, which is yeah, we could pick a small number of languages that are representative of different programming paradigms. But they won't be doing that because this gives little insight into programming as a unified discipline.
Mm.
Uh, which is again very different approach, right? Because usually when you're talking about multiple facets of programming, you would pick a language that is representative of each one. But we're going to go even further than that. We're going to try to abstract even more and say, okay, actually, we're going to talk about something called models of computation, right?
Yeah. And
Computation
then there's the
models.
title. Yeah, and then there's the title drop immediately after that, right? On the second paragraph of the preface, uh,
Second paragraph. We focus on concepts and the techniques to use them, not on programming languages. So this should be
I
completely programming language agnostic stuff.
yeah,
I totally missed the title drop there.
uh, oh, and there's also a heavy focus on practicality on here. He keeps. I think maybe the author was already ahead of its time and said, "I need to keep saying these buzzwords because then people would be convinced that, okay, this is not theoretical masturbation. This is practical. Okay, this is for production. Okay, calm
I
down,
mean,
people. Calm
as
down."
in, it is for programmers and not like trying to make a proof of it in math, you see? But not because it is a bad thing, just because, well, let's focus on this phase for now.
Yeah,
yeah,
and then we're gonna talk about a kernel language, which are kernel languages are introduced in a progressive way by adding constants one by one. So it's essentially like a language that fits all, that has it all.
yeah, and it's very small, very tiny, very focused. But then, because programming that would be inconvenient, we add some syntax sugar on top of that afterwards, right? That's why it's called a kernel language, because it's the kernel of the actual language that you then go and use.
Yeah. When stepping one model to the next, how do you decide on which concepts to add? So that's a very good question. A new concept is added roughly when programs become complicated for technical reasons unrelated to the problem being solved. So there are many examples of this, right? We can talk about boilerplate. We can talk about pointer arithmetic. We can talk about concurrency using explicit state. We can like there are many
Yeah,
things that become complicated, but not because the problem demands it, but because we lack better abstractions.
yeah,
So adding a concept to the kernel language can keep programs simple if the concept is chosen carefully. Which is like this brings another question: how do you choose one, right? So what do you use to decide? So that's going to be, I guess, further explored.
that's a very deep question actually.
Yeah. Well, we have multi-paradigm programming because we can mix models of computation together to create a better solution.
Lisp mentioned.
Yeah, Lisp mentioned. uh, okay, so then we're gonna have to go to the languages mentioned. So it's gonna mention Java, Smalltalk, SML, Prolog, Mercury, Haskell, Erlang. So Lisp, Scheme. Notice that there's no C in here.
Nope.
That's huge, right? Because according to Gabriel, the last programming language is C.
According to who?
To Gabriel,
Richard Gabriel.
that's a pun
Uh,
because the latest book that we read is from him, and he said that in there.
oh,
And then we single out four languages as representatives of important computation models: Erlang, Haskell, Java, and Prolog. And I bet you never expected to see those four languages grouped together like this.
And ML people are going insane, and I'm happy about that.
I mean, I don't know if you have Java or SML there. That's your C right there. It's literally the mutable reference. I mean, that's it.
We identify, yeah, that's it. We identify the computation model of each language in terms of the book's uniform framework. Okay, so goals of the book. We're gonna teach programming, guys. Damn, we're gonna teach programming.
Yeah, that's the goal.
Uh, this definition of programming is pretty interesting. So, a general human activity to mean the act of extending or changing a system's functionality. This definition is kind of weird because what if there's no system? What if you have to create one from scratch? You're not extending anything.
I mean,
Uh,
isn't the universe a system? Creating
damn,
something isn't just
damn,
configuring like programming.
damn. Um, uh, Okay, the step. Okay, in that setting, programming is a step between the system specification and a running program that implements it. The step consists in designing the program's architecture and abstractions and coding them into a programming language. Okay, so hear me out. There are two phases to this shit. We do something that we first call design, and then we do something called coding. This is a broad view, perhaps broader than the usual connotation attached to the word programming. Uh, yeah. Both
Yeah.
science and technology. So what are we going to do about those things? It's a technology because it consists of tools, practical techniques, and standards, allowing us to do programming. And the science consists of a broad and deep theory with predictive power, allowing us to understand programming. So that's pretty huge, right? Because you can do things that you don't yet understand.
Yes.
But you can understand things that you cannot yet do,
Perhaps because you lack the tools, right?
perhaps because you may lack the tools. And as a bonus, as a cherry on top, we would like it to be direct and useful as possible. That sounds okay. And if either part is left out, we're no longer doing programming. Which means every programming coach in existence is crying because now we are basically saying that, man, you need to know some math, man. Otherwise, you're not doing
You need,
programming. I'm sorry.
yeah, you need to actually
Well,
understand what
coding,
you're
right?
doing, right?
Without the technology, we're doing pure mathematics. Without the science, we're doing a craft. We lack deep understanding. I have a little bit of trouble with this sentence, to be honest, because I think that by doing craft, and you are very, if you're very into it, you're gonna eventually have some deep understanding. Not necessarily the same deep understanding you would have from the scientific approach, but I have a strong belief that people that are doing a craft for 25 plus years, they do have some deep understanding already. It's like
Ye-
inevitable.
Yeah, this is. I get what they're trying to say, but this could have been phrased a little bit better.
Teaching programming correctly, therefore, means teaching both the technology and the science. Knowing the tools prepares the student for the present, knowing the concepts prepares the students for the future. Um, well, then it talks a little bit more about the craft.
Yeah, and there's this one phrase here that I think is very true, but also very tragic, right? Um, each school of programming has its own science. The unity of programming as a single discipline has been lost. The last phrase on the first paragraph.
Yeah,
And the sad part is this is even more true today, right?
yeah, completely. This is also very true today. People don't, they don't understand that we are all in the same. We just explain things a little bit different, that we have different ways to approach problems, but we don't try to be a unity. We don't try to be a unity.
Yeah, and then there's the whole parallel with bridge building, which is funny because we just talked about it at the end of the last book, right?
Oh yeah, actually, I didn't notice that. Yeah, so Gabriel also finished the book talking about bridges. That's I didn't notice that. That's cool. So yeah, so we have bridge building again, but this time we're talking about different materials to be used. Like groups have dedicated their lives to understand how to create bridges with particular materials.
Yeah,
Graduates of either school would implicitly consider restriction to wood or iron as fundamental and would not think of using wood and iron together. And I think this is very true, right? Like memes aside, or even considering the memes, it's the C people saying that everything else is trash. It's the OOP people saying that objects are crazy good. It's the FP people saying that these older folks are crazy.
I'm not sure it's the same thing, Lemos. Uh, Regarding the bridges thing, it's not in the sense of I'm saying it is trash to build with iron, right? It is just that okay, that's what I do. then I think in this way. I'm focusing on that. It's
No, no,
not
no,
that
no.
I
I'm
find
more
the
talking
rest of it
about the
trash.
lack of unity. You were talking about this, right? And you were right. Nobody is saying, "Oh, your bridge with iron is trash because the mine with wood is better." In this paragraph, they're not talking about that. But I think this lack of unity, a symptom of the lack of unity,
Mm, mm.
is people attacking each other, trying to say that the other one's approach is trash, for
Yeah.
whatever reasons. And I'm not removing blame from myself. I have pissed people off by doing that. I am aware of that. Um, I am also to blame. Well, but I'm usually memeing and it's very explicit when I'm doing so. Uh, the result is that programs suffer from poor design. We give an example based on Java, but the problem exists in all existing languages to some degree. Concurrency in Java is complex to use and expensive computational resources. Um, but these difficulties are not fundamental at all. Uh, so I think this is very true that there is a lack of a single foundation for everybody to follow. So we can actually speak to ourselves to among each other more easily as well. And
Yeah.
then we have the kernel language approach. Um, so practical programming languages scale up to programs of millions of lines of code. They provide abstraction syntax. We can separate the language's fundamental concepts, which underlie their success, from their historical accidents. Can we? The kernel language approach shows one way. In this approach, a practical language is translated into a kernel language that consists of a small number of programmer significant elements. The rich set of abstractions and syntax encoded into the small kernel language. This gives both programmer and student a clear insight into what the language does. The kernel language has a simple form of semantics that allows reasoning about programs' correctness and complexity. And this gives a solid foundation to intuition and the programming techniques built on top of it. Yeah, I still find this idea a little bit, how can I say? How do you differentiate something like, I don't know, Mozart, which is what we're going to use from C++ land, you know?
How do you differentiate? Well, um, they are built on slightly different kernel languages, right? They have different, uh, slightly different models behind them. C++ assumes a model where, okay, you have a very low-level memory where you have bits and bytes, and you have other types that are built from those, but ultimately they are, in fact, bits and bytes, and the language acknowledges that, right?
Okay, so you're saying that both are kernel languages, but the difference is that one goes lower than the other?
Yeah, they have slightly different primitives in their kernel.
Mm-hmm.
That's kind of how you would think about it using this approach.
Mm-hmm. Okay, I see. Yeah, also, structural science lets one design all bridges and predict their behavior in terms of simple concepts such as the force, energy, stress, strain, and laws they obey. Yeah, this, like, regardless if it's made of wood, both, iron, both, or anything else, man, this is so good. This is so good. I like that. Then we go to comparison with other approaches. Um, and then we go to the foundational calculus. So talking about lambda or p calculus, and then we have the caveat, well, the pros and the cons. The pro is that this gives you a more an understanding of the fundamental properties and limits of that programming foundation, but it's not practical to write programs in them. And have written some programs in lambda calculus myself. I can definitely agree with this.
Yeah, like the point is, it's a very minimal formalism, which is nice if you're trying to prove things, but it's kind of a pain to programming because you really want to have some syntactic sugar, right?
Yeah, writing like a simple if expression in lambda calculus is already like, come on, man. What are we doing? What are we playing here?
Yeah.
A virtual machine defines a language in terms of an implementation on an idealized machine. A virtual machine gives a kind of operational semantics which with concepts that are close to hardware. Not necessarily. This is useful for designing computers, implementing languages, and doing simulations. This is true. It is not useful for reasoning about programs and their abstractions. Yeah, this seems very reasonable.
Yep.
And then a multi-paradigm language is a language that has, well, many paradigms. The usefulness of a multi-paradigm language depends on how well the different paradigms are integrated, which I think it's the criteria they chose the Mozart or OS programming language. Apparently, it is a language that the integration went well, maybe.
It is actually, and we will see a lot about it as we go through the book.
Yeah, no. Today we're not gonna be able to see, to have a glimpse on the craziness, which I probably will see in the future. Uh, but well, I trust this choice, their choice anyway. Uh, okay. Designing
Oh,
abstractions. Go
oh,
on.
this is another thing. No, no, this whole designing abstractions thing. This is another thing that we were talking about in the last book as well, right? When Gabriel said that designing abstractions is hard and should be left to experts, I don't think he
Yes.
said that in those terms
No,
specifically,
he
but
should. He did actually. He did say that in those terms.
well, remember, and then we were talking and we asked, okay, but how do you how do you learn this stuff? And well, this book is trying to teach us, so it's a nice follow up.
Yeah. So designing abstractions is hard. Designing abstractions is really hard. In my experience, is actually the hardest job because you need to do a commitment, and if you're wrong and you discover that later, it's gonna cost you, and
Yeah,
it's gonna be usually pretty expensive. Usually, programming a computer is primarily designing and
I
using
mean,
abstractions to achieve goals. Go, Mata.
doesn't that thing go to that thing we sometimes talk about regarding uh, how the creation of abstraction is made, as you foresee the patterns instead of just thinking about it and doing it,
No, but that's the thing.
as in
Sometimes you actually have the time and the luxury to allow the patterns to arise. So you have enough time that you can experiment and let the patterns uh, uh, announce themselves. That's not always true. You not always have the time.
yeah.
Sometimes
Sometimes,
you are obligated to make a decision beforehand.
yeah. Sometimes you have to say,
are we really well, how can I say, maybe it is not quite the same thing. Maybe there is a bit of a difference there regarding some interface and abstractions. Because for abstraction, I'm not sure that it's quite the a way for you to create that abstraction without seeing like uh, examples of it. Maybe you are talking regarding commitment to an interface,
No, 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 no,
right?
no. Okay,
Because
I see the confusion here. You're not n- not seeing. You are seeing. The difference is that are you seeing something in your in front of you right now, or are you trying to foresee something? That's the difference. So, for example, there are problems that you can immediately tell with enough experience, of course, what's going to be the best abstraction to solve that, even before writing any boilerplate or allowing the patterns to announce themselves. You can already foresee it. The
yeah,
problem is
but
that there are
because
some
you
problems
already
that you cannot
saw,
do
right?
that. Yeah,
Just
because you already
not
saw it, of
there.
course. The problem is that not all problems work like that. Some problems they have nuances and they have differences that may or may not influence in your abstract decision. And sometimes you cannot foresee those.
sometimes you're doing
That's
something
more,
entirely new, like you were trying to push the state of the art forward, and in that case, you definitely cannot foresee those, right?
Exactly.
but that's the thing, man. I don't think that is a way for you to do abstraction without seeing the cases. Maybe you are just talking regarding, okay, uh, I think I saw enough cases. I will set an abstraction here, but then I see more and okay, maybe the abstraction was not good enough. But
Yeah,
you
yeah,
cannot.
that's what can happen. You see?
I know, but Nathan is
Hmm.
saying that you cannot imagine a color that you haven't seen it. That's
No,
true.
it is not even imagining. It is in the sense of think on abstraction as in you see in your day, right? For example, the computer screen. You are abstracting over some very complicated stuff, and you have this simple interface. you cannot do the screen without having all the pieces before, right? You cannot go the other way around.
I don't know if I follow that because what Marinho and I were saying is that there is a problem, and maybe some parts of the problem we have seen before, but some other parts are still undisclosed, and you haven't had the epiphany that, oh, actually this is different than what I've seen before. This is actually not. I never seen this exactly like this before. And sometimes you cannot do exploration or investigation to learn the patterns to create an abstraction for the first time. Sometimes you have to do a commitment before doing exploration. That's what we were talking about. So, Nata, could you maybe rephrase what you're trying to say here?
Yeah, it is regarding how abstractions work, but the screen case, it is not good enough in the sense of abstracting repeating patterns, right? It is only to describe uh, how you make an abstraction after seeing something and not before it.
No, you have to see
Yeah,
it
but
first.
I think I see your point. But yeah, it is just that you didn't saw enough and
Mm,
you didn't had time to see it more
yeah.
before
Uh,
having to commit to an
yeah,
actual
let me try to
interface, right?
put it a different way to see if we can make it clearer. Sometimes you don't have time to go and see, so you have to guess. You see?
Hmm.
You have to guess, and you may have a very wrong guess, my friend. Very wrong. And sometimes you may be impressed by yourself, how good your guesses are. In my guess, that's actually a little funny. My guess is that your guesses get better as you have more experience, and it's very hard to understand why, like what influences your guesses. But I don't know, man. That's a little bit of a more of a craft than a science, I guess.
Okay.
We define abstraction loosely as a tool or device that solves a particular problem. Usually, the same abstraction could be used in solving many different problems. This versatility is one of the key properties of abstractions. Yeah, abstractions are everywhere. That's very true. Abstractions are particularly numerous inside computer systems. Modern computers are highly complex systems consisting of hardware, operating system, middleware, application layers, databases, programming languages, uh, DSLLs, DLLs. There are many things. They contain,
TLAs.
yeah, they contain enormous numbers of abstractions working together in a highly organized manner. But again, design abstractions is not always easy. It can be a long and painful process, as different approaches are tried, discarded, and improved, but the rewards are very great. It's not too much of an exaggeration to say the civilization is built on successful abstractions. Um, we are following we use the following approach to achieve the second goal. We start with programming concepts, which are the raw materials for building abstractions. So these are the building blocks that you're going to use to create abstractions. We introduce most of the relevant concepts known today, in particular electro scoping, higher order programming, compositionality, encapsulation, concurrency, exceptions, lazy execution, security, explicit state, inheritance, and non-deterministic choice. For each concept, we give techniques for building abstractions with it. We give many examples of sequential, concurrent, and distributed abstractions. We give some general laws for building abstractions. So yeah, and now the main features are pedagogical approach. There are two complementary approaches to teaching programming as a rigorous discipline. The computation-based approach presents programming as a way to define executions on machines. Uh, yeah, this is interactive development, right?
Yes, that's the logical conclusion of this eventually.
And then the logic-based approach presents programming as a branch of mathematical logic. So this is programming with paper.
Yeah.
Cool. And then SICK mentioned, right? So legendary.
Yup.
The book uses mostly the computation-based approach, so no pens, no paper and pencil for us. Concepts are illustrated with programs fragments that can be run interactively on an accompanying software package, which, by the way, Is this available on Nicks and Geeks?
Is this available on Nix and Geeks? That's a good question. Let's see, Mozart.
Why is that not on the website, Marinho? As
It's
in
not on. It's not on Geeks.
running.
Yeah, it's not on Geeks, unfortunately.
Damn! What a crime!
That's a
What a
good
crime!
question. Maybe I should try to package it. Actually, that would be nice.
Damn! You're welcome. Uh, this book uses a single formalism for presenting all computation models and programs, namely the OZ language in this computation model. To be precise, the computation models of this book are all carefully chosen subsets of OZ.
It's
And
Oz, as in the Wizard of Oz.
okay, so OZ. The main reason is that it supports the kernel language approach well. Panorama of computation models. Um, well, it's talking about the
Yeah,
models that you're gonna see throughout the book, I guess.
yeah. This is more giving us a flavor of what's to come. This will get expanded in the chapter one.
Yeah, which we're gonna talk about today anyway. So I'm gonna jump that. Uh, yeah, there are benefits on mixing them together.
Yeah, because
Because
well,
one does not program with models, but with programming concepts as ways to combine them. Depending on which concepts one uses, it's possible to consider that one is programming in a particular model. Certain things become easy, other things become harder, and reasoning about the program is done in a particular way. It's quite natural for a well-written program to use different models. And at this early point, the answer may be cryptic. It will become clear later. Uh, well, some concepts are useful for all the models, such as lexicoscoping and higher order programming. Why is lexicoscoping necessarily usually associated with FP though? I didn't know that.
because it
I
because of the lambda calculus.
Go, Nathan.
Man, I think it is something that we think as so fundamental. I even find it weird to be listed as okay.
No, no, no.
People
Eh,
actually
Okay, let me rephrase my sentence. If you really
no no
think,
no. I,
go on, go Nathan, go Nathan.
no, I know what you mean regarding the association. I was not commenting specific about that.
Oh, okay, but it is what Marinho said. It's because in lambda calculus, uh, when you have a lambda term, any of the particular terms being used inside the term, the subterms, you need to see them with the scope as close as possible lexically, right?
Yeah,
So even people make the argument that that's why shadowing should be okay. I actually had a debate about that in a Discord server somewhere when I was saying that I dislike shadowing, and they said, "But that isn't that the whole point that lambda calculus preaches?" And then they presented this argument to me, and I was like, "I can see the sense in it. I can see."
you can accept it but not like it, and I think that's actually a healthy position because shadowing can be confusing.
My problem is that how are you gonna in outwards something that you don't know where it is? I'm trying to debug something. I'm gonna read it in sequence. I'm not gonna read from the point of the term outwards. You know what I mean? So if I'm reading
Yeah.
in sequence, I don't know where I'm gonna stop because I don't know where the problem is to begin with. So, oh, this is doing shadowing and it's fine because that's what lambda calculus preaches. I can understand that, but at the same time, I don't know where that is to do that analysis.
Uh, Lemus, that makes no sense to me. Only because it is the case on the calculus, it doesn't mean it's fine.
No, but like if you think about it, it is fine.
No, no, fine as in should we do it? We can see why it is the case that maybe we start with this. It doesn't mean we should do it, right?
Um,
Okay, I
Other
see what
than
you're saying.
shadowing, yeah, yeah, and other than shadowing, the other feature of lexical scoping is closures, capturing variables, right? Um,
Closures.
that's also important.
That's also important. Uh, the limits of single models. Yeah, so essentially, uh, models have caveats. They can be improved by being mixed with something else. We're gonna see example of this in other places. This is the first time I see somebody criticizing currying to this extent. Like these are 5 lines against
Uh,
crewing man. That's a lot.
I mean, man, you should have experienced that already, right?
Well, I usually don't have
So,
a problem with it, but this argument I cannot deny this argument. This is true.
well,
Uh,
it is
Um,
enough that creating a language, I prefer to not have curry by default, but just a really good way to do the partial application.
yeah, here's a point, Lemus. Currying kind of forces you into the path of static typing because you need to be able to know, okay, how many arguments do I have to apply to this function? And
yeah, yeah.
if the function is curried, you need to know, okay, this is a function that returns another function that returns another function. You see?
Yes, I see. I see. If you have like variadics, like in the sense of you don't know how many are there to keep feeding it, right? You have a
Yeah.
problem.
In the most practical sense, you just have worse error messages, man.
That's also a thing. Yeah.
These examples are to some extent subjective. It is difficult to be completely objective regarding good programming style and language expressiveness. Therefore, they should not be read as passing any judgment on these models. Rather, they are hints that none of these models is a panacea when used alone, which I think is very fair. And then we're going to have to teaching from the book. So these are the main things: concepts and techniques, algorithms and data structures, programming design, and software engineering. And then it goes all about that they are entangled in some way. So teaching 1 requires teaching 3, and so on and so forth, which is very fair. And it talks about use the book as a textbook for several courses ranging from second year undergraduate to graduate courses. Second year undergraduate, what a privilege. But okay. Uh, it's not intended as
Wait,
as a first programming
can
course.
you expand there on the
What?
privilege?
Well, I would be very glad to have this in the second year undergraduate, as I was at some point in my life. Like this would be very
imagine
useful.
this.
Yeah, but
Imagine this alternate timeline in which Lemos got taught using this book on year 2 in
Yeah,
university.
yeah. Damn. It's not intended for as a first programming course to be used there, which like speaks for itself, right? As Nathan said in the beginning, it's not a book that you can uh, immediately have a grasp if you don't have some experience programming experience beforehand. Okay.
Yeah, yeah, this book is not really an introduction. It's like, yeah, you see this rabbit hole that you looked at the entrance. Let's dive deep into it. That's kind of how I think about it.
I think about it as a dark hole of programming. That's what I think about it. It's like it's the lessons that nobody want to teach to you, either because they don't want the competition or because they don't know. So you're gonna learn forbidden lessons that are very useful.
Yeah.
Um, okay, then it talks more about that. It's focused on practical education in the subjects going to be presented, which I think is fair. We're going to use
Yeah,
Mozart programming system.
that link is dead. You should look at mozart2.org instead.
Yeah, thanks, Nathan. That's cool. Acknowledgements, including the author himself.
And what's
Uh,
missing? Yeah, these 2 points are interesting
I
actually.
don't have this in my copy. This section, what's missing?
uh,
I wonder if your version of the book, because that's I think from a slightly later edition. I wonder if they added something about these.
Yeah, I don't have this in my paperback version. I'm reading the paperback version, of course. The formalism in this book is dynamically typed. Despite the advantages of static typing for program verification, security, and implementation efficiency, we barely mention it. The main reason is that the book focuses on expressing computations with programming concepts with as few as restrictions as possible. There is already plenty to say even within this limited scope, as witness the size of the book.
Yeah.
Pretty good. Specialized programming techniques. The set of programming techniques is too vast to explain in one book. In addition to the general techniques explained in this book, each problem domain has its own particular techniques. This book does not cover all of them. Attempting to do so would double or triple its size. To make for this lack, we point the reader to some good books on particular problem domains. Yeah, I also don't have this list. Okay. Final comments. Yeah, you can actually give feedback. I don't know if this is still a thing. Like, is this a mailbox? Can we send stuff there?
I have no idea.
Damn.
That would be awesome, though.
And then that's it for for that. And now let's go to the introduction. We have 15 to 20 minutes, so let's try. Okay, so introduction is pretty much baby steps to learning the language, right?
Yeah.
Whilst still also introducing some concept that we're going to explore in further chapters. Um,
Yeah, this introduction is basically here's baby steps into the language plus an overview of the rest of the book.
yeah. So we have this is how you call something. So you're calling browse, passing this to it, and
Yep.
apparently this is the like this is the delimiters that they use.
Yeah, it's like Lisp, except it uses curly braces for some reason.
Yeah. So it displays a result, which is the result of this operation, in a window called browser. When we say window, are we talking about is Mozart like a small talk type of system?
A little bit, yeah.
Oh, okay. So you can actually just randomly open a window, just like that.
Yep. Yep. There is a window in toolkits that comes with the system that you can use.
Okay. The curly braces are used to procedural function call. Browse is a procedure with an argument. And we have variables, which the book does. In the beginning, I was about to criticize this that it doesn't really define what do we mean by variables, but later this specifies mathematical variables. So this is more like labeling things.
Yeah, actually, it explains that there are two concepts. Yeah, right? There's the identifier and there's the actual store variable. But the store
Exactly.
variable is single assignment. You can only assign it once.
Exactly. So you have declare, and then you can do stuff like this. So v equals that. And they need to be capital letter, as far as I remember. The
Yeah,
identifier. They need to start with a
yeah,
capital letter,
yeah. It follows the same convention as Prolog.
which I guess is the same as Erlang's.
The same as Erlang's, yes.
They cannot be assigned more than once, so that's good to know. But if you reuse the identifier, you're gonna lose the stored variable from the past.
Yeah, it can. It you can do shadowing essentially.
You can do shadowing. The declare statement gets a new stored variable and makes the variable identifier refer to it. Then we have functions, right? So now we're gonna try to implement factorial, and this is the old school way, I guess.
Yeah, this is how you write it out by hand, basically.
Yeah, but then it gets impractical because of no obvious
Yeah,
reasons.
obvious reasons.
And then we can declare, and then we say that we're declaring that this identifier is a function that receives a thing that we're calling n, and then we do a check on it, and then otherwise we do something else, and then as Nathan pointed out, this is cool.
Yep.
What else it's important to mention here? We have if expressions, right? So if expressions, uh,
Something that I find quite interesting, the thing regarding uh, what was the order in which you learn stuff, right? Because eventually we all reach a point where we know a bunch of stuff, but it is funny to think about in which orders you learn some
mhm,
stuff.
mhm,
And I find it really funny. I started learn with something like C when CP and this book both just introduce without making a fuss about it. Okay, that's a variable. That is nothing regarding mutation here.
yeah,
That's just shadowing and recursion. Nothing special. That's just the way it is. And then, oh, this special thing, mutation and shit. And now I explain you this. And
Yeah,
well, it's usually not the way that is thought, right?
Yeah, that's
yeah,
not usually the way it's commonly taught to people. Which is a good thing because although I like to be contrarian, there's a good chance if it's against the trend, it's better than the trend. There's a solid chance, not a guarantee. And then we
yep.
can try to call factorial and open a window displaying its results. So this is the huge number. And then it comes the question of correctness. Can we tell that this is correct? And we're going to talk about this a little bit later. Then we have the Newton's binomial, right? I believe that's what this is called. Uh,
Um,
and this is essentially checking how many groups of R quantity can we make out of a group of N, right?
important operation in combinatorics.
Statistics? You have this in statistics?
Yeah, this is using combinatorics as well. So again, very simple. Just do a declare, and you literally it's like a verbatim of this in here.
Yeah, and the book acknowledges that, yeah, this is not efficient, but it's very simple because
It's
you're
not
calling
efficient.
factorial 3 times.
Yes, yes. Um, okay, then we go to the function abstraction, right? So it's always possible to use the existing functions to help define new functions. This principle is called functional abstraction because it uses functions to build abstractions. In this way, large programs are like onions with layers upon layers of functions calling functions. Then
Was
we
this
go.
before or after Shrek? This was before, right?
Wait, what was the question?
Was this before or after Shrek, the original Shrek?
Man,
Huh?
like, came out of nowhere
Wait,
that
you
one.
mean the movie?
Yeah,
It's
he's talking about
after.
the movie.
It's after. So yeah, large programs are like
You-
ogres, which are like onions. They have layers.
Wait, where is that from? The ogre. Well, I don't know how to say that in English, but having layers,
It's
the
from the
green.
Shrek movie.
Yeah,
It has that part about layers. Really? I don't.
yeah. There's a moment where Shrek is saying that ogres are like onions. They have layers.
What a random
Oh, is
reference,
that
man.
to Donkey? To
Yeah, to the donkey.
oh, okay,
And now Martin remembers. Even more
okay.
random. Okay, now we have lists. So we have Pascal's triangle, which is going to be the example moving forward until the end of the chapter. This is how they are going to be. This is how you should think about them. So linked lists are essentially like they work
You
like
have an
this.
element and you have the rest of the list. Yeah.
And then the end of the list is recognized by new, but because of historical reasons, and not
Yep.
open close brackets. And so it's a chain, and then it's explaining that the list has something that we call a head, and it has a tail, which is the remaining of the chain of things. And you also have an operation called cons, which is essentially how you put something in front of the list, like a new head.
And the term comes from Lisp.
And the term comes from Lisp. That's true. And then now we're going to try to calculate. Okay, yeah. So I haven't explained how do you calculate this thing. So the member on here is the sum of the members above it from and left and right. So 1 plus 2 is 3, 2 plus 1 is 3, and so on and so forth. So this is what's
Yep.
being explained in here.
Another comment
Go on.
regarding how people usually learn stuff, right? Well, data structures, man. People say it's nice to do them with C because then you can see the machine properly with pointers and stuff. But come on, man. Like ML or well, I think Lisp is a close second. But if you can learn data structures with ML, like look at how he's explaining Lisp, man.
Yeah, it's
You don't
completely
have to do the whole pointer.
yeah, it's completely
You don't need it.
disentangled. The operational, like how you're gonna implement that under the hood in the computer, and how you're gonna work with it. It's completely separate in this book, which to me is a really huge pro.
Yeah, it is just wildly better. Well, it is wildly different and well, miles better than what usually
Yeah,
is taught.
yeah. I don't like this thing though. This reminds me of
Rust.
Rust's touch.
Ah, it's freaking one based. That's what bothers me
That's
actually.
actually worse. That makes it worse. I Even if
I
this was
don't,
a zero and this was a one, I would still be bothered by it.
Marinho, I don't see the problem with being one based, man. Like elements are one base. The zero base thing is machine, right? It's the first element. You're not doing
Yeah.
calculations with offsets on a array of memory.
Uh, how can I? Okay,
Yeah.
basically there are two ways to look at the natural numbers. You can look at them as counting, in which case zero is the natural starting point, or you can look at them as a way to impose order, in which case actually one is the natural starting point because you go from the first to the second to the third. There's no zeroth, right?
Cardinals.
Yeah, cardinals versus ordinals essentially.
Yeah.
I just tend to think that the cardinal view starting from zero is a little bit more natural because
No, cardinal starts from one, right?
no, cardinal is counting, is quantity.
Oh, sorry. I
That's
got it
that's
opposite.
as opposed to ordinal, which is about ordering, right? It starts with one.
Yeah. Yeah. That's
And the reason for that is because of the modulo operator, actually. Like if you want to look at some value in a collection and you don't know in a list in a sequence and you don't particularly care about the size of the sequence, you just want to step around it in circles, then the natural way to do that is using the modulo operator, and the modulo operator actually goes from zero up to, but not including the
I
number that you
see
are
your
using.
point. I see your point. It would be much more practical regarding using the module and indexing to the element. But
Yeah,
I think they are separate things that just happen to often be used that way, and I don't think one should imply in the other.
okay.
mm,
Well, that's a separate conversation. I would still hate this if it was a zero and a one anyway.
that's
Uh,
fair.
um. Okay. Pattern matching. So this language has pattern matching. Damn.
It it does.
Yeah, I dislike something about it because as you can see, it's not complaining about okay, what if this pattern is not the one for L? Like you're not
Then
obligated to say that.
well, this is dynamically typed, so clearly, first of all, they can't check that because that would require static typing. But secondly, it's just gonna blow up.
Yeah, no, I figured that much, but I liked when they introduced the else later. Okay, but this is essentially pattern matching, so we are saying that there is a head and a tail, and if so, we're just gonna put the head and the tail in Windows, and this is essentially matching that this list has 5 as the head, this is the tail, and we move on.
Yep.
And can you remind us, Marinho, of the similarity of this and Erlang?
What do you
Is that
mean?
this is that the same or close to the same in Erlang? I don't remember the
Oh,
syntax.
right, yeah, because Erlang also has pattern matching as a primitive, and it's also dynamically typed. So in that sense, yeah, this is pretty similar actually.
Nah, I
I
don't think
mean, the
so.
syntax is
I
also
don't.
the same.
No. The syntax is different. Okay,
Yeah.
this is a nicer syntax.
And the else branch is also different in Erlang because in Erlang you need to say true or something. It's not else.
Uh, no, it's not true. You just have to say. I think you are forced to use a discard or a variable that says, okay, if it's anything else, and then right.
Oh, I'm confusing with the if. The
The
if is the
cons.
true in Erlang, right?
Yeah.
Yeah. Yeah, so pattern matching there. Yeah, the syntax is different in Erlang, that's true.
Also, can I just say that this actually, unlike Python, has the proper scoping for pattern matching.
Marinho, but I mean, that's the obvious thing. Man, in
Apparently,
my
it's not obvious
wildest
for.
dream,
Apparently, it's not obvious for Python people. But what can you do?
It's not
I don't
obvious.
know where they came from. It was not lambda calculus or some proper scoping thing. But in my wildest dream, I could not imagine such semantics for what they did in Python.
It's crazy shit, man. Crazy. Okay, now we're going to do operations on lists. So to do the calculation of the Pascal triangle, we need to do some shifts, which means essentially padding with ones and with zeros on both sides. and then we sum them up, and then that's going to be our answer for the next row of the triangle. And then again, so this is the process that's going to do that, and we need to do the forward declaration of the things. So we're going to use those things in here, but they're not yet implemented. That's the comment, the auxiliary functions. These are their implementations. So in the case of the shift left, you need to do a recursive process all the way to the end, because going to the end on linked lists is hard. And in the case of shift right, you just do this.
It's kind of sad that they are using linked lists. So shift left is kind of inefficient, but well, we're going to zip the two lists together anyway, so it's not terribly inefficient. It's just kind of annoying to see. But
Yeah.
what can you do? That's the data structure you have, so that's your option.
Yeah, and then the add list functionality basically like zips them over, right?
Yep.
And this is where we are presented with the case having an else. And this is
Yep.
required because of the recursive call in here, which is okay. And then we can actually calculate the 20th row, which is going to be this row. And then about this being right, it is symmetric. It has 1 and 19 on another side. Um, so we have some evidence that this seems to be fine. And then there is this comment about this being a top-down strategy to solve this problem, which is that we first write the top function, which is Pascal, and then later we'll implement the auxiliary functions. So it's from the top, and then the sub branches down, we do it
Yep.
afterwards. So that's a top-down approach, which I don't know. It varies to me for me. Sometimes I would like to do top-down. Sometimes I want to do bottom-up. It varies from problem to problem. Uh, Especially because sometimes I'm not sure that this is like sometimes it's not obvious that hey, I'm assuming shift left will be able to do its thing, but will it be able to? Maybe I should try to have answer that question before putting more time into into the Pascal function.
Yeah.
So now we go to correctness, and this is very important. We define a mathematical model of the operations of the programming language, defining what they should do. This model is called the semantics of the language. We need to define what we would like the program to do. Usually, this is a mathematical definition of the inputs that the program needs and the output that it calculates. This is called specification. We use mathematical techniques to reason about the program using the semantics. You would like to demonstrate that the program satisfied its specification. So this is not really hard. So you understand what things should do, you understand what you want them to do, and then you combine them together to see if one fits the other.
Yep.
So if you have a square hole, and you need to put a square there.
Yeah.
That is not supposed to be hard. Um, a program that is proved correct can still give incorrect results if the system in which it runs is incorrectly implemented. And what we're going to do about that? We're going to just trust me, bros. That's what we're going to do about that.
Yeah. Yeah. There's a whole field of like verification and making sure that everything is correct down to the transistor level. That's let's not do that. That's a very deep rabbit hole.
Yeah. And then we have mathematical induction, which is a way to do some sort of mathematical process to understand if our factorial function is implementing things correctly. This is not really something new, so I think this is fine for us to just pass over it. And then we go to the performance problems. So this function is very slow, and the reason is because we are calling Pascal function too many times. We're calling it 3 times, right? We're calling it.
Wow,
Yeah, we're,
twice.
we're calling it twice per nested call, which means like the top level is gonna call them 2 times, but then each of the levels below is gonna call it 2 times, which means you get 4 calls, and then you go to 8, and yeah, that's not good.
Nathan,
Hmm?
you were saying something.
No, no, twice, as in
Oh,
it's
twice.
called twice.
Yeah, no, twice in the body. I was counting this as well. One, two, three. Yeah, but that's very. It's exactly what Marinho said, and the way to that we fix that up is to essentially put that in a do the binding thing, and this is where I got confused because I was like, let L in, and then L equals. I was like, no, that's not how that works. Okay, so this is just
Yeah,
saying there is an L, there is an L, and this is it.
yeah. Being able to assign a value separately from from declaring the variable is important later when we get to concurrency. But right now, I agree that it's a bit weird if you're used to like ML style or Haskell style languages where you have let a equals whatever, right? In
Yeah. And then yeah, so we're essentially saving the result of n fast Pascal n minus one, and then just reusing it in here instead of duplicating the work. And there's no really gain in duplicating the work because you're just doing the same math as before. So this is a classic memorization issue.
yep,
One thing, Lemos.
Yep.
Well, we can see that that's only a problem because, well, laziness doesn't solve this, right? It is still duplicated work,
Yeah,
right?
it's still duplicated work.
yeah, it's duplicated work.
Okay. Yeah,
Well,
it
I
just
guess
made me. Mm,
no, it's just because
I,
maybe you could have a very smart compiler that is able to say that this is equal to this, and it
yeah,
optimizes the
but
shit
that's
out of
also the
it.
case in a not lazy
Yeah,
language.
yeah, yeah, yeah.
Uh, yeah,
Factoring
you
that
can
out.
do yeah you can do common sub-expression elimination. The problem is that um, if your language is not pure, then you need to be able to determine that this thing is pure, so it's okay to just call it once, you know.
Mhm, mhm, mhm.
And that can be complicated. So it's actually better to just say, let me just write it in
That's
the code
also
that.
orthogonal, right?
Sorry, Nathan, you cut off.
Also,
Oh yeah, yeah, yeah. Finish.
no, no, but
No,
you said something and it cut it off the internet.
yeah, yeah,
Oh yeah, it was like a while ago. I think it delayed somehow. But yeah, that's that you're saying is also orthogonal, right? Regarding being
Yes,
pure and you being
yes.
able to do the transformation, also orthogonal to being lazy and strict.
Uh, actually,
And
doing
the
the
thing I
transformation with an impure language in general is actually not sound because if you
Yeah,
just do the transformation and the function does some side effect, suddenly you're saying, okay, I'm going to do the
yeah.
side effect once instead of twice.
No, no, no. But Nathan is saying that there is what is orthogonal is the purity slash impurity versus laziness and strictness.
Yeah, that's orthogonal. I wouldn't want to use an impure lazy language. That sounds like hell.
oh man.
But yeah, they are orthogonal theoretically.
Yeah, and then we are essentially optimizing this to a polynomial instead of being like exponential. It's now a polynomial time complexity, which is well, again, this is not nothing new for any of us in here, so that's fine. And then we go to the lazy thing, which is just as easy as marking something as lazy, which is
Yep,
very cool, very cool. So you can essentially do the same shenanigans that you would do with like Haskell lists,
yep.
but they use the terminology of a future, which brings me to question. So they don't have like traditional futures,
They have transparent futures.
which I have no idea what that is, but well, we'll see.
Basically, a transparent future is called transparent because you don't explicitly force it. It's just there, and if you need the value, it gets forced automatically. The reason
Oh.
this comes about in Oz specifically is because a future is just a variable that has a trigger associated with it, and that's something you're gonna see later in the book. But yeah, a future is basically just a variable.
Yeah. So then we have more examples of the whole
By
list.
the way,
The list.
also regarding how Lemos, well, in the calculus, what is the usual way that people do reductions? It is in a more similar to a lazy way. Do they teach laziness first before strictness?
Technically, both they should produce the same result if they terminate.
Yeah, if they terminate.
Yeah,
Yeah,
but
but
I
there are
mean
names for that.
regarding
Is it
the
like
I'm
norm,
teaching
heavy
you
normal?
laziness first, or Well, probably the standard way doesn't even fit on the Haskell or strict way. It's probably
Uh, well, actually,
even
yeah.
a different one.
Yeah, there are names. One, the strict order evaluation is also called call
Yes.
by value. And
Yes.
then there's the normal order evaluation, which is also
Yes.
called call by name. And it's called by name, which is different from Haskell, which does call by need. And the difference is in Haskell, if you evaluate an argument, that only gets forced once and then memoized. That's why it's called call by need, because it only evaluates when it's actually needed. Uh, if you just do normal call by name and you use the same variable twice, it's going to have to be evaluated twice.
Mhm.
You just substitute a complex expression and well,
Yeah,
duplicate work, right?
yeah.
Yeah. Yeah. Yeah. Yeah. Okay. Yeah. So again, another example of lists. Lazy calculation of the Pascal's triangle. Yeah, which is essentially marking this as lazy and like doing the cons operation here, and then we can just grab the rows. Pretty normal stuff.
Pretty normal stuff.
Yeah, you can do a short circuit in here,
Yep.
starting from the initial, and then direct calculate those rows. Higher order programming. So now we are coming to the realization that having hard coded the binary operation is it kind of sucks. So
Yeah.
classic problem. Classic problem. So now we're going to pass the operation ourselves, and the body of everything else is the same. And this is called higher order programming. And now we can essentially just pass whatever operation we may want, including addition, exclusive OR, minus, use something from what seems to be a prelude.
Yeah.
And then
And
we go
then,
to the concurrency thing.
yep.
So we would like our program to have several independent activities, each of which executes at its own pace. So we want this plus to be waiting on these multiplications, and these multiplications each one waiting for their variables.
Yeah.
And to do that,
That's kind of the next, right? That's not from there yet.
well, that's kind of what, Nathan?
That's kind of from the next point. That's not regarding the concurrency yet.
Well, they're related, so, you know.
Yeah, yeah.
Yep. We introduce concurrency by creating threads, and we just put the thread keyword in there.
Yep.
They share memory, so somewhere in yeah, share the same underlying computer. Well, I actually don't like that this is kind of vague because like threads and processes are sharing their underlying computer, but they are different.
I
Uh,
mean, if he's not explaining all the details, it is just like doing naturally, introducing the things without explaining much. That's
Yeah,
just the
this
natural conclusion, right? That you have the same variables available and stuff.
yeah.
yeah, this is an overview, so it doesn't go into too much detail. But yeah,
Yeah.
it is kind of vague. I agree.
Um, yeah. So yeah, we have a thread in here, and now we will come to the data flow thing. Which yes, as Mariam predicted, this is the thing that I never seen before. So it's called a data flow when there is a civilized behavior in which uh, an operation would simply wait for something else, for another thread to do the stuff. So in this example, we want to, this browse multiplication thing is going to wait until x is bound. And that's only going to happen after 10 seconds.
Yeah,
It
because it's
just
on a separate
waits.
thread.
So this waits for stuff. And then vice versa, right? So you have this thread which wants to do the multiplication, and the x is only going to be bound 10 seconds after. So there's that.
Yep.
And you can radically change the appearance of the program, adding more threads. But as long as the same operations are involved with the same arguments, it does not change the program's results at all. The key property of this is the key property of data flow concurrency. This is why data flow concurrency gives most of the advantages of concurrency without the complexities that are usually associated with it. Yeah, so it's kind of nice that you can have like, in a way, this is like embedded locking mechanism.
It kinda is, yeah.
And now we have state, which is like explicit state, which is well, Lyceum uses explicit state, right? So we have full control of the mutable cell that we call state. We give a pointer, a mutable pointer to everybody, so everybody can touch it.
Yeah, we have a ref using for keeping track of some PDL stuff behind the scenes
No, 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 you're already
because, well,
confused. I said Lyceum.
oh, Lyceum. Oh, right, Lyceum. That is true because Lyceum is, well, oh, it's freaking Zig, right? There's no way, there's no
It's
way to run
freaking
away from,
Zig.
there's no way to escape from doing mutability over there, I suppose.
No, no, but there is a way. We could, instead of passing a pointer to everybody, we could have like methods. That would be the only public way to interact with the state, and that
Yeah,
would
that would
turn the
be,
state into an object.
yes, but it would still be state. It's just encapsulated.
Yeah, exactly. Uh, so yeah, this is being done via what's called the memory cell, which is pretty much Clojure atoms or OCaml's refs, as far as I can
Yep,
tell.
it is.
So the syntax is even like also kind of similar. So this is how you declare stuff, this is how you read stuff, and this is how you write stuff.
Yep.
And if we do it like this, everyone has access to C, and in this case, Fast Pascal is leveraging that fact. But another other function could do the same thing, and that's why it's called explicit state. When you add encapsulation to this process, that evolves to what is called an object. So in here,
Wait, Lemus. I'm not sure that what the explicit is about.
No,
Isn't
no.
that
The reason this is called explicit state is because you can also have implicit state, which doesn't look like normal state because it can be used declaratively, but it's still state at the implementation level. For instance, if you have a tail recursive loop, right?
mm,
The accumulator in this case is implicit state because you keep updating it on each iteration of the tail recursive function, right?
yeah, but that is exclusive. The only one that has exclusive access to that is the function, right? Nobody else has access to it. That's why it's called
ah
implicit.
Yeah. Well, it's
Yes.
mm,
actually it's implicit because there's no visible mutation, even though there must be some mutation going on in the runtime to make sure it doesn't take up space, you know?
yeah, I don't think it is about the encapsulation.
It isn't.
That's what I understood from it though, because the way that that is being depicted in here, the main difference between this code and the code below, which is well, explicit state versus objects, is that this one is encapsulated, the other one is not.
Yeah, it is not a versus, it is a plus. And then a plus this, and that's called encapsulation.
Yeah, if you have explicit state plus encapsulation, you get objects. But you still have explicit state, it's just encapsulated.
No, but I'm not saying objects are not explicit state. I'm just saying that what Marinho said, you can evolve the explicit state into an object by using the encapsulation thing.
Yeah, you can.
Um, Wait, but I just want to go backtrack a little bit. So implicit state is no observable mutability, right?
Yeah, like there must be mutation going on in the runtime because you are
Yeah,
recycling storage essentially,
yeah,
but it's not observable in the semantics of the language, so it's implicit state.
not observable in the semantics of the language. Okay. Well, we talked about this before, right, Marinho, about Haskell. Anyway, I remember that
Eh,
conversation.
Yeah, Haskell doesn't actually have explicit state unless you use unsafe perform IO.
Yeah. Anyway, so now we have the object. So now we have a local, which I have well, actually that's fine. This is just like declaring the C. This is defining the C, and these are providing the quote-unquote methods for C. The cell is referenced by a local variable, so it's completely invisible from the outside. And
Yeah,
this
this
is
is the
what we did in Karuta, right? This is the
yeah this is
PDL
the
thing.
Yeah. This is the classic let over lambda pattern. If anyone knows that book.
I don't, but I believe you. Yeah, so in Karuta, what we have? We have a store module, right? We have a memory module that we created in OCaml. And in there, we have a mutable reference that is not accessible via the module signature. So the people using the module cannot touch it, but they can call functions that have access to it.
Yeah,
So yeah, so this is precisely what we did there. Which again, this resignification of what these things mean kind of makes that, oh, actually we're using objects in Karuta, even though we're not using
yeah.
OCaml objects.
We are not using OCaml objects, indeed.
Uh, um, we can guarantee that the counter always work correctly no matter how it's used. This is not true for the extended fast Pascal because anyone could look at and modify the cell, as we've seen before. And then we can bump it twice, uh, and so on and so forth. And then we have classes. What do we do if we need more than one counter? It would be nice to have a factory that can make as many counters as we need, such as a factory called a class. So now we can define, well, this doesn't have syntax for it, so this is just a function, right?
It's just function. It's an impure function because it creates a mutable thingy that it returns, right? And it creates a fresh state each time you call it. But yeah, this is just a normal function.
Yeah, and then you declare these three things beforehand. Then you define C, you define bump and read, and you return what is called a record.
Yeah, this is kind of like a functor from Prolog, except it's labeled instead of positional.
That's weird. The record counter bump read is characterized by its label counter and by its two fields. So you can just literally call it like that.
But I mean, Lemos, that's always the case, why? Right? All the records are just tuples, man. Like literally.
No,
But
no,
you
no.
have names at the.
No, no, no. I'm not surprised about records being this way, just because uh, it came out of nowhere. Oh, this is a record. Okay.
Oh yeah. That's very weird.
Okay. And let's jump this figure. This is misplaced. And then there's more examples. This is how you call the method of the record. So this is like new counter and
Yeah,
new bump.
you just access the field, which is a closure, and you call it.
Yeah, and then there's
Pretty
a difference
normal.
between object-based programming and object-oriented programming. So operations defined inside classes are usually called methods. The class can be used to make as many counter objects as we need. All these objects share the same methods, but each has its own separate internal memory. Programming with classes and objects is called object-based programming. When you add inheritance to object-based, it evolved again to object-oriented programming.
And we only look at it in detail in chapter 7, which is very far away.
Yeah. And now we have non-determinism and time. So now
Yup.
we go to the problem of interleaving.
Yup.
So if you have this program, you cannot be sure that the end result of this will be either one or true. You can't know
Yup.
because of the interleaving problem that it's gonna be exemplified by this figure here.
Yeah, it's observable non-determinism.
Yeah, so you have the definition of C, and then C equals 1, C equals true, but the other way around is also possible due to the interleaving of the two threads, and then you cannot know beforehand what exactly is going to happen. And then we have this other example using the increment. What is the content of C after this program executes? It looks like each thread just adds 1 to the content, making true. But there is an output. 1 is an available output of this program. And then it introduces
Yeah,
the
if
interleaving, which is essentially
yeah,
when the CPU swaps which thread is running right now, and then you have this order of execution, and you end up with 1.
yeah,
Because
if
this reads
both
0.
reads have
Mhm.
yeah, if both reads happen before both writes, then yeah, you can get one, which is very surprising.
Very surprising.
Well, it doesn't need to be both reads. You only need one, and then if that does the writing after all the others, then the final is one, right?
No, it needs to be both reads before both writes, not done, because If I do
Huh?
read and then I do write as well, let's say I do write as well. So C is containing 1. When it's turn for this to read, it's going to read 1 and then it's going to do 1 plus 1, which is true.
I mean, if the first one does the read,
Yeah.
then the other does read and write, then the
Uh, yeah.
last write from the
I
first
suppose
read
that's also well, but in
will
that case,
set to
both
one,
reads.
right?
Yeah, but in that case, both reads happen before both writes. Either way.
Oh, in this case, yes.
But that's not what Manatan said. I don't think it's true. I read 0. You
Hmm.
read 0 and wrote 1. And it's my time, and I am 0 plus 1. And I'm going to write 1 again. I'm going to overwrite the 1 with another 1.
Yeah,
So what Nathan said is also going to culminate on a 1, not a 2.
yeah.
Well, but that's what I said. Like, if the first read uh it is done, then the other can do read and write, and that's already enough to end in a one. It doesn't need
Ah,
to
you were saying that
all
they're
the
going to end it on
read.
a 1. So never mind me. I
Yeah,
understood you were
as
saying that this would end in 2.
yeah, as long as both reads happen before the writes, then yeah, you're gonna get a one, no matter which way you order the writes afterwards.
And how do you solve that? Transactions. Dab, 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 dab. Damn.
Well, I think coordination or synchronicity would be
No, no, no. But the big
more
father
simple.
of this is transactions, right? Am I wrong?
I
Atomicity.
mean, I think you are going on the more complex idea, as in you got the building blocks and did this abstraction.
No, he's no.
But
He says transactions himself. Where is it?
what I mean is, this is the thing composed of simpler ideas, and
Ah,
you.
okay, okay, okay. No, I can buy that. But at some point here, he mentions transactions in this thing. Anyway, to solve that, you just add a lock to it, which essentially means that you're gonna pause a thread if another one is already using, basically like a mutex or a semaphore, something of that nature. And that will lead you. Actually, there's a question here that I think we should answer. You need lock on both of them. Why? Let's answer that question.
Because if you don't, then one thread is gonna grab the lock,
Yes.
uh, and then the other is not gonna look at the lock, and both will access the same resource regardless. So
Yes.
locking just one doesn't help.
Yes. Yes, that's pretty much it. Uh, yeah.
And that's the overview.
And that's pretty much it. And then we have exercises here. I just have one last question about what you said in these locks here. So both threads will go through. The lock is being on C, right?
No, no, the lock is
No,
L.
no,
No, no,
there
the
is
lock is
no.
that's the name of the L, the lock. Sorry, I'm talking about what are they protecting? They're protecting C,
It is
right?
the scope, Lemus. It is not any particular variable. It is a scope.
No,
It's the
so it's
Yeah,
block
all
that
of
you
it.
are locking.
yeah, it's protecting the entire block from lock until the corresponding end.
Okay, so the two threads will read these, and the first one will go through, right?
Yeah, the first one is going to acquire the lock and go through. The other one is going to see the lock is taken, and it's going to wait until the lock is free again.
And when the first thread is done, it's going to go to the second one, right?
Yes,
What
and the
happens to
second
this?
one,
Yeah, go.
yeah, and the second one may not necessarily be the second one textually. It's just the second one that by the interleaving got the lock later.
By the interleaving got the lock later. No, 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 it's
Yeah.
fine. It's just because, like, if we have two threads and we have two locks.
Oh, if you have two threads and two locks, that doesn't help you either. They have to be the same lock on both threads.
Wait,
Ah,
are
okay,
you
that's
asking
that.
what
No, no,
happens on the contention
no, 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 no.
when
I
they
was
both
just
try
confused
to get
because
locked?
I forgot that it's the same lock, right?
Yeah.
So, how can I
Oh,
say? One thread is going
yeah,
to be
it's the
paused and the
same
other
L,
one is
right?
going to go further. And then they may swap it, right? So another the second thread may go through this first lock here after
On
the first
mutual
one is done.
runs, right?
Yeah, I'm
Yeah,
just concerned that we're gonna have answers with more than true. That's kind of what
Huh?
I'm thinking
yeah,
about.
no, no.
What do you
What
mean?
happens is you have two threads. Each thread will try to lock L, and whichever one gets there first is gonna win, and the other has to wait.
Yeah,
And
but
then
it. Mhm.
when the first thread that won is done with L, it's going to exit the lock block, which is going to unlock L and allow the other threads to proceed.
No, no, no. This makes sense. No, this the answer is always true. This makes perfect sense. Uh, yeah, and I think then we have exercises, which I haven't looked at it, but doesn't anything here seems outrageously hard. And then we
Not
have
really.
general computation models on part two.
I'm
Well,
I'm s-
the exercises on the first chapter are not hard, but there are some, like, the exercises actually have a difficulty marking on them. And some of them, the book actually says some of them are actually open research problems, just thrown casually as an exercise in this textbook.
Damn, damn. Okay, folks. So that's it for today. So any final comments before I finish the recording here?
Bridges.
Man. Wait, what is the word?
Bridges.
Bridges. Go on, Nathan.
Oh. I'm just thinking about the thing again, man. That's dense. That's very dense if you are like new to all of it, man. Like imagine that would be that would be good, but I would complain doing this class, man. Uh, for sure.
You would complain.
Yeah, it would be a pain. I'm not sure if I would enjoy at that time, right? Like
No, you
right
gotta be
now, I
ready,
can
man.
appreciate that.
You gotta be ready. You gotta be ready.
Well, that's the thing. I don't know if previous Nathan, without experience, would appreciate that, right? Sometimes you only come to appreciate with time. Maybe I would
well,
just complain that's hard.
well, the book is very clear, right? It's not really intended for first year.
No, yeah, but I cannot not think on that, man.
I cannot not think on that. Yeah, I can relate to that. Anything else, folks? I'm gonna finish the recording now.
Bye, future people.
Bye.